Rahim. Assalamu alaikum. This is second part of lesson 5, creating and leveraging data structures. In our first part, we studied some commonly used array functions. Mainly we covered four commonly used array functions. Number one, array size. Second, array subset. Third, build array. Fourth, index array. Alright, now we will use some more commonly used array functions and LabVIEW. The fifth one is the initialize array. Basically, initialize array creates an n-dimensional array in which every element is initialized to the value of same element. So suppose you initialize this array with element of 4.2, so every element is expected to be 4.2 and the dimension size is 3. So 3 elements will be there and every element will be 4.2, and this will be the resulting indicator array shown in the front panel. It is basically a resizable node. So you can resize the node and mention number of rows and number of columns, and say suppose you want every element to be 1 with 2 rows and 3 columns. So in result you will get 2 by 3 matrix and every element will be 1. Let us practice this thing in LabVIEW. Alright, so let us use initialize array function. Let us make every element to be 5 and let us make dimension size to be 4. Let us create an indicator. So at indicator we expect to see every element to be 5 for 4 elements, means dimension size is 4. Extend it. So this is the output. Alright, as per expected. Let us use this initialize array and let us resize it. Let us make every element to be 2 and let us make the number of rows to be 2 and let us make columns to be 3. So this will result in an array with 2 rows and 3 columns, and every element is expected to be 2. This is the output as per expectation. Okay. So this was basically we learned how to use initialize array. Alright. Now let us discuss another sixth commonly used array function, which is insert into array. Insert into array is used for inserting an element or subarray at the point you specify in index. Say suppose you want to insert this subarray at the index you want to define, which is index is 3. So 0, 1, 2, 3. 3 is this index. So this will result into indicator matrix with 7, 3, 2, and then this array 7, 6, 2, then 5. So this will be the resulting output 1D array. So it inserts one subarray at the point you specify in index. This is a function of insert into array. Similarly here, it inserts this subarray at the row number 1. This is 0 row, this is first row. So 0 row will be 735, then first row, this will be the subarray in first row 762, and then this row 412. So this will be the resulting matrix. Alright, let us use this insert into array in LabVIEW. Let us take insert into array function. Alright, so let us mention the index. Say suppose index is 2 and at 2 index we want to insert this subarray, and we want to see at the output array. This is the output array. So you see at output we expect to see 5 0 1 2. So 5 4, then 1 2 3, then this will continue 8 9 5 3 2 7 6 8. This is the output. At index 2, which is 5 4, index 2 0 1, this is the index 2 5 4, then this subarray 1 2 3, and then this continues 8 9 onwards. Alright, this is the function of insert into array. So it inserts a subarray at the point you specify in index. Alright, let us use this function into multi-dimensional arrays. Alright, then mention the row where you want to insert. Say suppose row is 1, and say suppose this is the subarray. Alright, this is the subarray, and let us create its indicator. So at first this will be the zeroth row, then and on the first row this row will be inserted, then this will be the second row at the output. Alright, let us see output here. So you see this is the expected output. So this is the expected output. You see this is now first inserted into row number 1, this subarray, and then this is the row number 2. Alright, this is a function of insert into array. Let us move to our 7th most commonly used array function, which is delete from array. Basically, delete from array is used to delete an element or subarray from n-dimensional array of length elements starting at index. Returns the edited array in array with subset deleted, and the deleted element or subarray in deleted portion. Say suppose you want to use this delete from array from this array matrix. What should happen here is that length is 2, means 2 elements will be deleted from index number 1. So this is index number 1. So 3 and 2 will be deleted, and remaining you will get 7 and 5. So this is the resulting output array, and this is the deleted portion 3 and 2. Similarly here you want to delete 2 rows from starting from row 1. This is row 1, and if there will be row 2, this will be also deleted because 2 rows are asked to be deleted. If there is only 1 row, this is not present, so this will be deleted, and if it was there any row, it would have been also deleted. So the resulting output will be 735, whereas this 412 and the next row, if there was present, will be deleted. Alright, so this is the function of delete from array. Let us use delete from array function in LabVIEW. Alright, go to array, click delete from array. Say suppose you want to delete how many elements, what is the length? Say suppose 3 elements you want to delete. And what should be the index from the point where from the elements should be deleted? Let us say index is 1. Let us create, this is the remaining our array, and this is the deleted portion. Alright, so now 3 elements will be deleted, length is 3 from index number 1. Index number 1 is this, so 4, 8, 9 will be deleted, this will be deleted portion, remaining will be our array. So let us see the output. Now you see 4, 8, 9 is deleted, 3 elements from index 1, and the remaining this array is present. So this is the operation of your delete from array function. Let us perform this delete from array function into a 2D array. Say suppose you want to delete length, you want to delete one row and you want to delete basically row number 1. So this is the row number 1. This row will be deleted, only this 0 row will be available because array is 0 index. Similarly, you can create indicator here, and you can also create indicator here. Alright, drag it. So you see, this first element will be, first row will be deleted. So this is the result as per expectation. Alright, this is deleted portion, this is array available. Alright, now let us discuss ninth array function, which is search, which is basically array max and array minimum. This array max and array minimum returns the maximum and minimum values in array along with the indexes of each value. So it returns maximum value and also its index, it returns minimum value and also its index. So suppose in this case the maximum value is 7, it index of 0, you see, this is the result, and minimum value is 2, it index of 2. In this case maximum value is 7, it index of 0 row and 0 column, you see, 0 row 0 column, and here the minimum value is 1, it index of first row and first column. So this is a function of array max and array minimum that returns maximum minimum value and also defines its index. Let us use this function in LabVIEW. Alright. Pick max and minimum function. This one. And create indicator. All controls and indicators. So all indicators will be created here. So it will, and the maximum value is 9, its index will be shown, and the minimum value is 2, its index will be shown. You see, maximum value 9, its index is 3, minimum value 2, its index is 6. Similarly, you can use this function also on two-dimensional array. Let us use on two-dimensional array. Similarly, create all indicators. So now you see in this case maximum value is 9 and its index will be shown, and minimum value is 0 and its index will be shown. So 9 is at index of 0 row and 3 column, and 0 is the minimum value, its index is first row and first column. Alright, so this is how you use array max and array minimum function. Let us move ahead. Search 1D array. Now basically search 1D array searches for an element in 1D array starting at start index. Because the search is linear, you need not sort the array before calling this function. Let you stop searching as soon as the element is not found. Say suppose you use search 1D array here and you want to search 5. So you can see 5 is available at index number 2. So index this will be shown that this element is available at index number 2. This is how you can search any element from even a very lengthy array. Here in this case, say suppose you want to find element number 8, but this element number 8 is not present over here. You also define from which index to start search. Let us say you want to start searching from index number 0, means from very beginning. So you see from very beginning the number 8 is not present in this array. If the number is not present, then you will get result of -1. -1 indicates that the number you want to search is not available in that array. Let us use this search 1D array function. Alright. Go to array, use search 1D array, and say suppose you want to search from search element number 9, and you want to start your search from index number 0. Create indicator. Now you know that this 9 number is available at index number 3. If you want to search here, let us say 1. You know 1 is not available in this array, so it will result in -1, showing that this is not available, not found. Alright. So now let us perform this activity phi1 using array functions. So we will complete the highlighted portion in each VI. So let us move to participant guide. So description is each of the VIs shown has missing information. Determine what belongs in the highlighted section. So which function of the array should you use in order to get this output result? Every element is 15. Dimension size is 4 rows and 7 columns. So this is certainly function of initialize array. So initialize array performs this work and the result will be like this. So here you want to search 1D array, the element is 12. If you see element 12 is not available in entire this array, and you start searching from index 0, if this is not available, it will show -1 here. This will be, the answer will be -1. Let us come to this question. Here you want to insert the array. This is the subarray you want to insert at row number 2, 0 first. So this will be 7, 3, 5, 15, 0. This will be second, first row will be 4, 1, 2, 17, 0. Then second row, this will be subarray inserted, 17, 14, 25, 28, 26. 54 will be discarded. 54 will be discarded because this length, this number of elements will be matched. So this is how many elements are there? 1, 2, 3, 4, 5. Here are 6 elements. So 6 element will be discarded. Alright. This 54 number will be discarded. Alright. Then our third row will be 21, 12, 16, 17, and 18. Alright, so this will be the result. Similarly, delete from array. You get this output. So you see how many rows are deleted. Basically, 2 rows are deleted. So length is 2. And from which index are deleted? From row 1 are deleted. So row will be 1. 2, 1. Then this will be the output. You can see the solution here. This is the solution of activity 5.1. Alright. Now we will discuss the concept of polymorphism. So let us discuss the concept of polymorphism. Alright. Objective is to understand the ability of various VIs to accept input data of different data types. So what is polymorphism? It is basically the ability of VIs and functions to automatically adapt to accept input data of different data types. So basically we want to know that either the function or the VI can accept different data types or it has not the capacity to accept different data types. So its capacity to accept either input data of different data types is called basically polymorphism. So functions are polymorphic to varying degrees. None, some, or all of the inputs can be polymorphic. Some functions and some VIs accept numeric or boolean values. Some functions and some VI only accept numeric or strings. Some accept scalars, numeric arrays, or clusters of numerics. So every uh, different functions and different VIs can be polymorphic up to certain extent. Maybe they are not polymorphic and they accept only restricted and defined kind of data type, and maybe some functions accept every kind of data type. So up to varying degrees, different functions have different capacity of polymorphism. Leview arithmetic functions are polymorphic. You see, you can these this function add function can take scalar data type as well, can add array with scalar as well. You see, it can add array of two same lengths and two same size array. It can add array of two different array size. Like this has 3 elements, it has 4 elements. Now if this first matrix input has 3 elements, the fourth element will be discarded and the output will be up to only 3 elements. So now you see that the add function is arithmetic function, and this arithmetic function is basically, this is a polymorphic function, and mostly arithmetic functions are polymorphic. They can accept basically different data types, be it scalar, be it array. So array arithmetic functions are basically polymorphic functions. So in our third part of lesson 5, we will start from auto indexing. Thank you very much.